Every 60 seconds, a new Toyota rolls off a line in Kentucky. But the real reason that line matters now isn't just the speed. It's what that line is about to build next and how it could blindside Tesla and BYD without Toyota ever trying to out-Tesla them. The story starts in the 1980s, when Toyota was already famous for building cars that didn't break. The American market wanted more of them, but there was a problem. Trade friction made it risky to ship everything from Japan. So Toyota made a bold call: build a full-scale plant in the United States. The place they picked wasn't Los Angeles or Detroit. It was Georgetown, Kentucky. Why? Access to highways and rail, a skilled workforce, room to grow, and a bet that Toyota's quiet production philosophy could take root far from home. In 1988, the first US-built Camry came out of that Kentucky plant. It didn't happen fast. It happened right. Toyota brought something unusual with it. A way of building that looked slow because it kept stopping. That was the point. If any worker spotted a defect, even a bolt at a weird angle, they pulled a cord called an Andon. The entire line stopped. A supervisor rushed over. The problem got fixed on the spot. This wasn't theater, it was a rule. Toyota called the idea Jidoka, automation with a human touch. Let the machine do the heavy lifting, but let humans decide what good looks like. That same system had another pillar called just in time. Don't pile up parts. Don't waste motion. Deliver the right piece at the right moment, in the right number. Sounds obvious. It wasn't in the 1980s. Most factories tried to hide mistakes under mountains of inventory. Toyota did the opposite: reduce buffers, so problems show up instantly. Painful at first, powerful over time. It turned Kentucky into a classroom. Every new hiccup taught the team where to tighten the system, where to speed up, and where to slow down. By the 1990s, the plant kept expanding. Stamping presses the size of houses turned flat steel into doors and roofs. Robotic welders stitched body panels together so precisely that gaps between panels looked laser-drawn. Paint booths layered primer, base, and clear coat in dust-free tunnels. And the final assembly lines clicked like clocks. Seats here, dashboards there, engines fitted down to a hair. The goal wasn't to push people. It was to cut the wasted steps that push people in the wrong way. Then Toyota did something gutsy. In 2015, it moved production of a Lexus ES sedan into Kentucky. That meant Toyota trusted Kentucky with its luxury badge, no excuses. Same plant, higher bar. And the cars kept coming. The site sprawled to about 1,300 acres, bigger than 1,000 football fields with more than 8 million square feet under roof. On busy days, over 2,000 vehicles walked out the door. From raw steel to a running car could take less than a shift. But the stopwatch flexed to quality, not the other way around. You can measure the factory's rhythm. 1 minute, 1 car. It sounds like a trick until you see the choreography. A coil of steel rolls into stamping. 10 seconds later, out come fenders. Body parts travel to welding. Sparks fly as robots place thousands of tack points. Each one checked, each one traced to a serial number. Painted shells glide to assembly. Engines and hybrid systems drop in. Wiring harnesses snake through the dashboard. Tire torque guns beep only when they hit the exact spec. At any point, a worker can hit the cord and stop it dead. They do. That's the culture. And yes, it can annoy new managers. But the cars that pass through those hands almost never return for avoidable issues. Toyota knows that stopping for 1 minute beats recalling hundreds of cars for 10 minutes each. Here's where the human-robot relationship gets interesting. Toyota didn't flood the plant with robots to replace people. It plugged them into jobs that hurt backs, bruised wrists, or demanded inhuman repeatability. Pick up the 80-pound doors? Robot. Track a paint line within a few millimeters on the 100th car of the day? Robot. Decide whether a texture on a panel is a surface issue or just a trick of the light? Human. Catch that faint rattle that shows up only when a trim piece sits just off-center? Human. Robot consistency plus human judgment. Not flashy, but brutally effective. But something else was brewing inside Toyota that would turn effective into strategy. In 1997, Toyota launched the Prius in Japan. It was the first mass-produced hybrid car, part gasoline, part electric. Back then, people laughed. Hybrids were slow. They were weird. They were a science project. Toyota kept going. By the mid-2000s, the hybrid system, the power split device that pairs a gasoline engine with 1 or 2 electric motors through a smart gearbox, was no longer an oddity. It was a weapon. Let's make it simple. A hybrid is 2 power sources in 1 car. At low speeds, the electric motor can move you quietly. Sipping from a battery, when you need more power, the gas engine kicks in. A small brain decides which one does what, second by second. There's no shifting like a normal transmission. It's a smooth gear set that blends power. The result? You get the power of a bigger engine when you need it, and the fuel use of a smaller engine when you don't. It's like having a sprinter and a marathon runner take turns with your legs based on the stretch of road. The numbers matter here because they tell you why Toyota bets so hard on this. A typical mid-size gas sedan gets around 30 miles per gallon. A Camry hybrid can get up to 51-52 mpg in many trims. That means you use roughly 40% less fuel to go the same distance. Over 15,000 miles a year, that's hundreds of dollars saved, often more than 1,000, depending on fuel prices in your city. A RAV4 Hybrid SUV sits taller and carries more than a sedan but still returns around 40 mpg combined. The Prius, the latest generation, can hit 57 mpg, and yes, Lexus does it too. The ES 300h returns around 44 mpg while feeling like a lounge on wheels. Now for the part most buyers worry about: the battery. Toyota's hybrid batteries have an 8-year 100,000 warranty in most states, and 10-year 150,000 coverage in states that follow California's emissions rules. Taxi fleets around the world have pushed Prius batteries past 200,000 and even 300,000 miles. When they do wear out, Toyota recycles them. In the US, Toyota partners with Redwood Materials to recover materials from old packs. The idea is to pull copper, nickel, and lithium back into the supply chain, instead of mining new metal every time. It's not just green PR, it chops risk out of Toyota's parts pipeline. But wait, this next part changes everything. Hybrids made Toyota profitable and resilient. They also bought Toyota time. While the world argued over whether EVs would win fast or slow, Toyota kept building millions of hybrids and quietly funding the factories that could build batteries at scale in America with American workers. Just down the road in North Carolina, Toyota is building one of the largest battery plants in the country. The official name is Toyota Battery Manufacturing, North Carolina. It's a multi-billion-dollar site with multiple production lines designed to build both hybrid and full EV batteries. Toyota has already expanded the project several times. When it's fully up and running, it will pump out dozens of gigawatt-hours of cells per year. If gigawatt-hours sounds abstract, here's a sense of scale. 1 gigawatt-hour can supply roughly 10,000 EVs with 100 kilowatt-hour packs. Dozens of gigawatt-hours is enough to power hundreds of thousands of cars yearly. And now loop back to Kentucky. Earlier this year, Toyota committed another $1.3 billion to the Kentucky plant to prepare for a new, 3-row battery electric SUV that will be built in the United States using batteries from North Carolina. This matters for 2 reasons. First, it locks Toyota's supply chain inside the US, qualifying the vehicles for tax credits and smoothing logistics. Second, it puts EV assembly into a plant that already hits a car per minute with precision. If you thought Toyota would only build hybrids here forever, try this: that 1-minute line is being reconfigured to build the hardest vehicles Toyota has ever attempted, full EVs, next to the same workers who built your Camry. Let me tell you this: Toyota is not copying Tesla's style. It's using Toyota's style on a new kind of car. Tesla's factories use huge Gigacast machines to turn giant chunks of a car's frame into single-cast parts. It reduces the number of pieces and welds. It's smart. Toyota watched. Then Toyota ran experiments. Toyota's engineers found a way to cast large modules too, but bolt them together in a sequence that makes the car easier to repair and reconfigure across different models. They also started prototyping self-propelled assembly. Instead of pushing cars along a fixed conveyor, each unfinished vehicle can drive itself through parts of the line at a steady walking speed that allows sections to move around or to be rebalanced without shutting the entire plant down. The payoff is flexibility. When you're adding EVs into a line that still builds hybrids and gas engines, flexibility beats raw speed. And here's where it gets wild. Toyota says it's targeting a next-generation EV platform in 2026 with better aerodynamics, shared battery systems, and a software brain called Arene, built to update like your phone. Then, by 2027-2028, Toyota claims it can launch solid-state batteries at scale. Solid-state means replacing the liquid inside a battery cell with a solid material. Why bother? 2 big reasons. First, safety. Solid electrolytes don't flow or leak like a liquid, and they can be much more stable at high temperatures. Second, performance. In the lab, solid-state cells can pack more energy into the same space and take a charge much faster. Toyota's public target is eye-catching, up to around 620 miles of range on a single charge, with the ability to recover a major chunk of that range in about 10 minutes. If they can hit even part of that goal, charging stops start to feel like gas station stops. But what if I told you Toyota isn't waiting for that moonshot to move the needle? Before solid state, Toyota plans to ship next-gen lithium-ion packs that cut costs by up to 40% compared with today's packs, and lithium iron phosphate packs called LFP. That sacrificed some range for big price and durability advantages. LFP is BYD's specialty. Toyota's plan is to deploy it widely in more affordable EVs. Meanwhile, they'll keep improving their hybrids with bipolar battery tech that makes nickel metal hydride packs smaller and more powerful. It's all part of what Toyota's leadership calls a multi-pathway strategy. In plain English, sell the right tool for each market at the right time. Full EV in places where charging is easy. Plug-in hybrids in places where it's growing. Hybrids where it's not. Hydrogen fuel cells for heavy-duty and fleets. Speaking of hydrogen, Kentucky started assembling Toyota fuel cell modules for Class 8 trucks. These modules replace a diesel engine with stacks that combine hydrogen and oxygen to produce electricity, with water vapor out the tailpipe. It's not a fit for your daily commute yet, but for ports and distribution hubs where heavy trucks run fixed routes, it's a real option. Toyota is building those modules in the same state that builds Camrys. That's not an accident. It's a bet that energy systems will fragment, and Toyota wants a piece of every slice. Okay, step back. How do we know this approach actually works outside of slide decks? Reliability is one clue. In recent years, Consumer Reports and other long-term studies often rank Toyota and its luxury brand, Lexus, at or near the top of all brands for dependability. Not because their cars are flashy, but because little things don't break. The same mindset that lets a worker stop a line over a suspect bolt is the mindset that keeps your seat heater from dying 2 winters in. When you build hundreds of thousands of cars a year in one place, small percentages become big numbers. A 1% reduction in defects on a line making 500,000 cars equals 5,000 fewer bad cars. That alone can swing profits and brand trust. Now the conflict. While Toyota was counting pennies and shipping millions of hybrids, Tesla sprinted into the EV future. BYD sprinted too, but with a different playbook. Tesla built software-first cars with fast charging, sparse design, and factories full of giant castings. BYD integrated everything from raw chemicals to batteries to motors and sold millions of new energy vehicles in China, including many plug-in hybrids. By the end of 2023, Tesla delivered about 1.8 million EVs. BYD sold over 3 million new energy vehicles, roughly half of them full EVs. Toyota, in that same year, Toyota sold millions of hybrids, but only a small slice were full EVs. Critics said Toyota was late. They said Toyota would lose the next decade. You thought that was big? Try this. Toyota didn't deny the criticism. It changed CEOs. In 2023, Koji Seto took the top job and said plainly, "We will speed up EVs, but we will not abandon other pathways." Then Toyota started dropping receipts. Billions for the North Carolina battery plant, $1 billion plus for Kentucky's EV build-out. Open testing of large die-casts. Plans for next-gen EVs that cut development time and cost by using shared software and components. And the line in Kentucky kept producing Camry, Lexus ES, while the teams trained on high-voltage safety, battery handling, and new assembly routines. Let's put dollars and cents on the table because buyers do the math even if companies don't. A 2025 Camry is hybrid-only in the US, with a starting price in the high $20,000s. It returns around 51 mpg in many trims. For a family that drives 15,000 miles a year, at $3.50 a gallon, that's about $1,030 in fuel. A comparable gas-only sedan at 30 mpg burns about $1,750. That's more than $700 back in your pocket each year. A RAV4 Hybrid starts in the low $30,000s and gets about 40 mpg. Many compact SUVs in that class return 26, 30 mpg. Over 5 years, that difference can pay for a lot of insurance, tires, or the road trip you keep postponing. Now put that against a Tesla Model 3, which starts around the high $30,000s. Electricity is cheaper per mile in most parts of the US, and home charging is convenient if you have a garage. But if you live in an apartment or drive long distances through rural areas, the hybrid's ability to refuel at any exit still wins on stress saved. This is the nuance Toyota is betting on. EVs are great where they fit. Hybrids are great where they don't. And if Toyota can build both on the same campus with the same quality, it doesn't have to pick one winner. It can let customers pick. That's not indecision. It's an anti-fragile strategy. But wait, there's a twist buried in the Kentucky plant itself. The same halls that once only built engines, transmissions, and sedans now house training labs for high-voltage systems. The same Andon cords that stop the line for a bolt now stop it for insulation resistance checks on battery modules. The same stamping presses that form roofs now feed experiments in casting larger chassis pieces. And the same workers who trained on torque specs for lug nuts now train on milliohm checks for battery bus bars. Toyota is taking 35 years of muscle memory and rewiring it for electrons. Let's walk the line in order and make it real. On one side of the plant, coils of steel arrive by rail. They move to stamping. Each coil can become hundreds of parts. The presses are fed by robots, but every shift begins with human checks on the dies. One nick in a die turns into a bad panel every 10 seconds. The line stops if it happens. Stamped pieces ride to body weld. A white body takes shape on a platform while up to 100 robots work above and below, adding thousands of spot welds. Humans check door fit with gauges that measure gaps to fractions of a millimeter. The body goes to paint, where it gets dipped to prevent rust, dried, sprayed, dried again, then polished under bright lights. In final assembly, a car that looked like a shell becomes a person's next 4 years of life. Wires, glass, seats, steering wheels, engines, or hybrid transaxles join from a subline. The car starts for the first time on a test bench and drives itself off a roller onto a small track for brakes and alignment. Under all of that is a takt time 1 minute per station. If something's off, the Andon lights flash. A team lead runs. The line pauses. The problem gets fixed, logged, and fed back into the system so it doesn't happen again. Now imagine that with battery packs. Instead of a fuel tank, there's a protective battery case. Instead of a gas line, there are thick orange cables that carry hundreds of volts. Workers double glove, check clearances, and follow new lockout procedures. High voltage systems add risk, but they also add software checks. If a sensor sees a temperature spike in one module, the pack can isolate it. If the pack does need service, Toyota's goal is to swap modules instead of whole packs, where possible. That keeps costs down and cars on the road. The modules themselves will come from North Carolina, but Kentucky will marry them to the vehicle and test everything before a car ever sees a highway. And here's a detail that sounds small but matters. Toyota's software stack, Arene, is being built to update the car over the air like Tesla does, but with Toyota's obsession with redundancy. Cars, when they leave Kentucky, will be finished, not half-baked, and waiting on a patch. But they will evolve. Better energy management can add miles of range without changing a bolt. New driver assist tweaks can smooth out how the car follows in traffic or steers through curves. The idea is to keep the Toyota feel predictable, trustworthy, while adding the modern ability to improve. But can Toyota beat the charging problem? That's the next question. And Toyota's answer isn't to build its own supercharger network overnight. Instead, it's to align with the emerging standard NACS and let third-party networks scale while Toyota brings vehicles that can use them. It's less heroic than planting fast chargers every 5 miles, but it follows the same logic as the factory. Don't duplicate what someone else can do well. Do what you can do best at ridiculous scale. Let's talk emissions and energy for a second, because the Kentucky plant isn't just cranking out cars and calling it a day. Toyota is pushing toward carbon neutrality at its factories, adding solar arrays, recycling water, and capturing waste heat. The biggest lever, though, is building vehicles that burn less fuel over their lifetimes. Every hybrid that returns 50 mpg removes gallons of gasoline use every single day. Even if you don't care about CO2, you can understand the supply chain logic. Less fuel burned means less exposure to price spikes and geopolitics. It's boring. It's also how you keep a brand alive for 100 years. But it gets crazier. Toyota's Kentucky team isn't just building cars and walking away. They also build engines and, now, fuel cell modules. That means the plant is a training ground for mechanical and electrical talent. It can flex for new models without hiring an entirely new workforce. When the 3-row EV arrives, many hands will already know how to handle high-voltage systems. When solid-state batteries show up, many hands will already know how to treat packs with the respect they demand. This kind of cross-training is a moat you can't see on a balance sheet until a crisis hits. Of course, none of this wipes away Toyota's missteps. The BZ4X, Toyota's first modern EV, launched with a wheel hub issue that led to a stop sale. The press pounced. Toyota fixed it, but the hit was real. Meanwhile, Tesla kept selling in huge numbers, and BYD flooded markets with well-priced EVs and plug-in hybrids. China, Europe, and the US all grew in different ways. Toyota's answer isn't to pretend the stumble didn't happen. It's to quietly fix the weakness and out-execute long-term. Now let's wrap the numbers back into the story. Suppose Toyota's North Carolina battery plant produces enough packs for several 100,000 vehicles a year. Suppose the Kentucky line can build a mix of hybrids and EVs at its usual pace and quality. Suppose the next-gen EV platform in 2026 hits targets of better efficiency and lower cost. And suppose the solid-state battery arrives in 2027, 2028, not at lab perfection, but good enough to put 500-600 miles into a family SUV with a 10-minute charging stop. You don't need to beat Tesla at software cool or BYD at cost per kilowatt hour to change the game. You need to make an EV that millions of people already trust, at a price that doesn't scare them, built in a plant that has been earning trust 1 minute at a time for 35 years. So, does this mean Toyota will surpass Tesla and BYD? It depends on the scoreboard you use. If it's pure EV sales today, Toyota is behind. If it's total electrified vehicles, hybrids, plug-ins, fuel cells, Toyota has led for years. If it's profitability per vehicle across a lineup, Toyota and Lexus are an elite company. But if the scoreboard is the future, the Kentucky plant is the clue. In a world where many automakers bet the company on one path, Toyota built a factory system that can build many. It can switch between them, mix them, and scale them up or down without breaking the machine. And here's the final piece that loops right back to that first minute. The magic of the Kentucky plant isn't that a car comes out every 60 seconds. Lots of plants can go fast. The magic is that when a worker yanks that cord, the entire company listens. That culture is about to meet the biggest shift in cars since the engine itself. If Toyota can take the discipline that made a Camry boringly excellent and bring it to batteries, motors, and software, Kentucky will do more than build a car a minute. It will build a future where you don't have to choose between new tech and old trust. But wait, this is the part I didn't tell you yet. The first US-built Toyota EV rolling out of Kentucky won't be a niche city car. It's a 3-row family hauler aimed at the heart of the American market, powered by American-built batteries, rolling down a line where every minute carries 35 years of muscle memory. If that lands, the entire EV chessboard shifts 1 square toward Toyota, not because they shouted the loudest, but because they moved the quietest. And in this factory, quiet usually wins. So, the next time you see a Camry or a Lexus ES gliding down the highway, remember what's humming behind it. A plant that looks like a small city. Stamping presses that move like thunder. Robotic arms that never sleep. And humans who can stop everything with a pull of a cord. 1 minute, 1 car. Soon, 1 minute, 1 battery electric SUV. The rhythm won't change, the energy will. And that's the point. The story that began in 1988 isn't ending. It's speeding up. The clock is still ticking. The question now is, when the new line hits full pace, who's ready to keep up?